Hello guys, welcome to the video. In this one, I want to show you how to make movement of the camera by touching edges of the screen. Simply by moving mouse up, your camera gonna go forward, something like that. It's gonna be pretty easy to do. Let's add header over here, edge movement details maybe, and we're gonna do serialized field, private float, and let's do edge threshold equals to 10. So this is the threshold of the screen. For example, it's like that. And we're going to do 10 on all sides. And when you touch in some part over here, it's going to move. And we also want to have private float screen width. And we want to have private float screen height. We can get these two in the start. Start, screen width, screen height. Okay. Very good. Now let's go maybe somewhere below, make a method, private void, handle edge movement. Now in this method, you'll notice that there is some similar code to what we had over here. And to be honest, all of these methods could be combined with some calculations that we could use for all of the methods, for example, target position or anything like that. But I want you to be able to switch off some of the functionality if you wish to do so. For example, we're going to have here edge movement. And if you wish to switch off movement with the keys, you're just going to go here and comment this out. That's why we're making each method sort of independent. Okay? And that's why you're going to see some repetition of the code, but it's okay. This will allow you to have more flexibility without need of adjusting the code. That's what I want to do here. So now inside of this method, we need, first of all, target position. So we're going to make vector 3 target position equals to transform position. We also want to know mouse position. So we're going to do vector 3 mouse position, and it's going to be equals to input mouse position. And we also want to have this flatten out vector, just like we did over here. So I'm going to just copy it, go back, and paste it in, like so. All right, so how it's going to work? We have screen width. It's going to be stored in the variable, and we know the value. For example, it is 720, okay? And we're going to check mouse position on the X. If it is bigger than 720 minus the edge of the screen, so if it's 720 minus the threshold, which is 710, so if it's bigger than 710, then it means we're trying to move to the right, and we're going to move camera to the right. If position of the mouse is less than threshold itself over here, then we move into the left. Same goes for the vertical calculation and vertical calculation on the minus. Yeah, so this is how it's going to work. We can simply do that by checking mouse position over here. If mouse position.x is bigger than screen width minus edge threshold, means we are too far on the right and we need to take target position and make it plus equals transform right multiplied by, and we probably should have a variable for the speed as well as the velocity. Completely forgot about that. Let's go over here and do serialized field, private float, edge movement speed. Let's make it equals to 10 by default. We're going to check how it works. And over here, we want to add a new vector, private vector 3, edge movement velocity equals to vector 0. Okay, let's go back to the method and use these values. Gonna go over here and do transform rate multiplied by edge movement speed multiplied by time dot delta time. Then if mouse position dot x is less than threshold, then it means we move into the left, and target position should be minus equals transform rate multiplied by edge movement speed and time dot delta time, like so. Then if we trying to move up, we're gonna do this check. If mouse position dot y is bigger than screen height minus edge threshold, then target position gonna be plus equals flat forward multiplied by edge movement speed and time dot delta time. Same goes for the movement down. If mouse position dot y is less than edge threshold, then target position minus equals flat forward multiplied by mouse, edge movement speed multiplied by time dot delta time. All right, kind of simple, right? Similar to what we did before, but this time instead of checking input with the vertical and horizontal keys, we just checking if mouse is outside of the boundaries we set. We just check if mouse is on the edge of the screen. Now we're just gonna take transform position, make it equals to vector 3.smooth dump from a transform position to a target position with a ref, edge movement velocity, and smooth time. Simple as that. And again, this method is very similar to this method over here, and perhaps we could combine them in some way, but I want you to be able just to comment this out without any changes. That's why we're doing it like that. Handle edge movement. Later on, if you don't like edge movement, you just go here and do it like so. If you don't like mouse movement, you go here and do like so. Okay? Very nice. Let's go ahead and try this. Gonna go to the game window with a full view. Like that. Let's go to play mode. And now I can move my mouse up and move forward or backwards or left or right. Probably should be faster. That can be adjusted with the variable over here. For example, 120. Okay, let's see this. Yeah, works very well. It works even with the two edges at the same time. There is nothing else to adjust. Kinda like it. This is how I usually play games, to be honest. I just move the edges, barely use the keys, but I thought it would be nice to show you all of the options. Then you can choose what is the best for your game. Okay. Now, as I mentioned before, wait, what is with the header over here? Let me see. Should we combine this? I'm gonna combine this. And I'm gonna make it as 50 by default. Okay. Once again, if you want to switch it off, just go here and comment this out. All right. Now let's go to the next video. Probably I'll switch it off because sometimes I go to the second monitor and moves the camera. Yeah. Now let's go to the next video because we have something else to do. I'll see you there.